Okay, Dua beta. Now, let me just recall you what we are already done. This is basically the course of algebra, geometry, right? So,
Yeah.
what we are trying to do, what happened basically when we will study properly about the geometry, at that point we have to make reasonings. Okay, so currently we are preparing ourselves for the reasonings. Okay, how we can make reasoning and how the logics, how we can relate the given idea to get the output. Okay, so initially we were done with the logical reasonings. Now we are on the step where we will study about the algebraic reasoning. You know very well, when we are learning about any geometrical shape, we can convert it into algebraic form, and then we will apply the algebraic reasoning and logical reasoning to conclude to get some results. Okay, that would be the whole process during the course of geometry 1. Is it clear?
Yes.
Okay, so now we are going to study about some very basic and very fundamental concepts of algebra that you know very well, but we will just recall them. So here is the first property, what we call it. It is the algebraic properties of equality. Now, for example, you have some real numbers a, b, and c. What are the real numbers? Real numbers are basically, they can be rational or they can be irrational. Or in other words, we will say if we sum up, or we will take the union of rational and irrational number, we will get real numbers. Okay, now what is the first property? It is the addition property of equality. Though it looks very difficult here, what it says basically, it says that, for example, if two real numbers are equal, means if we say a is equals to b, two real numbers are equal, then if we add a same number, if we add a same number on both sides of the equality, the result will remain same. If, for that means if I add
Oh,
c on
so
both sides, it will remain same. For example,
if like A and B is 7 and
yeah,
C is equal to 6, then it would
okay,
be 13 is equal to 13.
yeah, if c
Wait.
is 6, then 7 plus 6, that would be equals to 7 plus 6, so
And
we
then
will
it
get
will be
13
13
equal.
is equal to 13.
So basically what is, this is not 13 equals, okay, the main thing is that this relation between the real numbers, this is a relation. Now this is the equality relation. This equality relation will remain preserved if we add same number on both sides of the equality. Is it clear?
Yes.
Okay, similarly, there is a subtraction property of the equality. What does it mean? It means if two real numbers are equal, if two real numbers are equal, for
Mm-hmm.
example, again a is equals to b, and you are subtracting a same number from both sides, then the result will remain same. Again, let's take 7 is equals to 7, and we are subtracting, consider c is 6, so if we are subtracting 6 from both sides, then the equality will remain same. Okay, there is no effect on the equality relation. Okay, we are familiar with these properties we are using when we are solving the algebraic equation, but they can be solved by using these properties. Without these properties we can't solve those examples. Okay, and the next is the multiplication property of equality. What does it mean? It means if two real numbers are equal, then you are multiplying with the same number on both sides, and there is a condition on the same number that it is not equals to 0. Why we need this condition? Just
Because
example.
if you
Hmm.
multiply any number with 0, it's gonna be 0.
0 equals to 0, right? And it is a trivial case. Okay, so that's the reason we are having this property. Similarly,
But the numbers, it
mhm,
cannot be zero, but it can be any negative or positive
it
number.
can it can it can be any negative or positive number. Excellent, very good. I think there is no need to give you example related to that, right?
Yeah.
Okay, the next is the division property of equality. What does it mean? If two real numbers are equal and you are dividing both of them with a non-zero number, by doing that, the equality will remain same. At this point, the division by a non-zero number is only possible. We cannot divide any number with zero, right? So
Right.
that, yeah. So again, if we are dividing them with a positive non-zero, with a positive number or with a negative number, the result or the equality relation will hold. And okay, then the next is very interesting property.
Substitution property
Subs
of equality.
Equality, yeah. If a equals to b, then a can be substituted for b, or b for a in any equation or expression. For example, uh, if I say that a equals to 7, okay, this is the equality
Then
between,
you can also
and I have
substitute.
and I have the expression a plus 7 is equals to 0, then I can substitute it here. Okay, I can substitute this value of a here because already I have a equals to 7. So what we call this property, this is the substitution property of equality. So we studied five properties of addition. One is sorry, five properties of equality. One is the addition property of equality. We can add the same number on both sides. Then it's a subtraction property of equality, that we can subtract same number from both sides. Then multiplication, then division, and then substitution. Is it clear?
Yeah.
Okay, now I am going to solve a problem with the help by using these um, relations or these equality properties. For example, very easy question. If I just give you this question, you can tell me the answer, but let us solve it by using the basic and the fundamental algebraic reasoning. Okay, 6x minus 11, that is equals to negative 35. Okay, now what I am doing, I am adding positive 11 on both sides. Which property allow me to do that? It is addition of equality,
Right.
right?
Hmm.
So with the help of addition property of equality, I can add this number on both sides. So you did that, okay, so you will get negative 24. Yeah, now I am dividing both sides with 6. Which property allow me to do that? It is division property of,
Equality.
yeah, division property of equality. That property allow me to do that. And we got x equals to negative 4. Excellent. Now we solve the same question, but with the help of by using the basic properties of equality. Okay, if
Hmm.
the just imagine if these properties doesn't true. For example, these properties are not true in case of the inequalities. Some of the properties are not true in case of the inequalities, particularly the division property and the multiplication property. So in that cases, we have to use those properties. Okay, so now what you have to, moving towards again towards the main problem, which is basically related to geometry. What we have to do, you will be given with a relation. Okay, if there is a equality relation between two angles, then we can apply these properties. Clear?
Yes.
Okay, the next is the distributive property. This property is basically uh, what it how this help us. If again you have the real numbers a, b, and c, then you can distribute if it is in this form. What does this mean?
With
Eh,
in a parenthesis form.
In the parenthesis form, what does it mean? It means basically if you are adding b and c and then multiplying a with it. If you are adding first b and c and then multiplying a with it, it is equivalent. It is equal to, the result would be same if you just multiply a with b, then multiply a with c, and then add these two terms. Okay, for example, just suppose that the value of a is -7, the value of b is 2, the value of c is 3. Okay, so just check, are they would be equal or not. So -7, I'm replacing a with -7, b with 2, and I have to replace a with -7 and c with 3. So now see, -7, 5, is that equals to
Negative
negative
35.
14 plus,
Right.
step by step beta.
Oh,
Okay, negative 21. Clear? Now
right.
negative 35 on the left side, and when we add them we will get negative 35 again, right? So that's indicate that the property holds true. Similarly, if there is a subtraction, means if you are subtracting two numbers and then you are multiplying a number with it, so it is equivalent, you just multiply the number outside the parenthesis with both numbers and then subtract them, the result will be same. Clear? Now
Mhm.
by using this distributive property and by using the properties that we already learned, let's apply let's apply them to solve a question which is 3x, sorry, 3x plus 14,
Is
then
equal to negative
it's
3.
3 that is equals to -3. Now I can't do it further if I haven't a distributive property. Because I studied the distributive property, then by applying the distributive property I will get, this is same as 3 times 3x, okay,
Mm-hmm.
plus 3 times 14, that is equals to -3. Which property I used? Distributive property of addition.
Wait, I have a question.
Yeah, beta.
Like, let's say, like, besides that, could you divide
We
three
can, we can,
parentheses?
we can. Property
So
of,
then, if you divide like both sides, it will be -1, and then
yeah,
three.
yeah, we can do that. The basic purpose is not to solve the questions right now. Okay, keep it in your mind.
Mm-hmm.
My target is not to solve these questions. We already solved these questions in grade 8, right? We
Right.
already practiced these type of questions. The basic purpose right now is to understand these properties, is to understand the idea that whenever we are doing a single step, there is a reason. That's why today I named that board that we are learning about algebraic reasonings. Okay, there is a reason. With the help of the reason, I can move forward. If I haven't, I cannot move. Okay, now look at the next step. Can I multiply 3 with 3x? No, currently it is not possible. But yeah, if I just do this property, which is the associative property of real numbers, usually we learned it in grade 8. That means if three numbers are being multiplied, I can shift the parentheses. Okay, so by using that property, now I am able to multiply 3 with 3. Okay, this is multiplication sign right now. Plus 3 times 14 is, what is 3 times 14? It's 42, right? That is equals to -3. And which property I used this time? It is associative property. Associative property of multiplication. Is it clear? Now 3 times 3 will become 9x. Let me just correct it. Plus 42. The result is negative 3. Okay. Now I have to subtract, okay, 42 from both sides. I can subtract the 42 from both sides. Which property I am using now? This is basically the subtraction property of equality. Okay, this is subtraction property. This is due to the subtraction property of equality, that if there is an equality relation, I can subtract the same number from both sides. Okay, now it will become 9x. What is 42 minus 42? It is 0. I think while doing it quickly, I forget to write that property. Then what is 3 minus 42? The result is negative 45, right?
1. Oh, wait. Yeah.
Okay, now what is 9x plus 0? 0 is the additive property, additive identity of real numbers. Okay, so means whenever you add 0 in any real number, the answer would be the same real number. We call that property of 0. So it is 0 property. Some of the time we say that, or some of the time we say that it is the additive identity uh, of real numbers. So 9x plus 0 will give us 9x, that is equals to negative 45. And how I am able to do that? By using the additive identity.
Mm-hmm.
Even though the subtraction, when I say positive 42 and negative 42, they are giving me 0 because they are additive inverses of each other. Okay, this is all about the reasons. Additive inverses. Okay, moving forward, now my target is to divide both of them with 9. I am dividing both of them with 9. Why I can divide both of them with 9? The question is not this time why we had to divide with 9. The question is why I am able to divide with 9, right? Which property makes me able to do that? So it is the division property of equality. It allows me to do that. Okay, so negative 45 divided by 9 is negative 5, and I did this by using the division property of equality. So are you getting those equations which you can solve in just a minute, or lesser than a minute? They can be solved with these type of logics, right?
Yeah.
So there is a reasoning again, and I think there is no concern to solve question number 5 and question number 6 even, because you are good in solving the questions. But the main target is to solve them by using the properties. Okay, is just to give you the idea that each property that we are writing, each step from step 1 to step 2, there is a logic. Same thing is going to, it you will see when we are solving the geometrical problems. You will see that how each step will be related to the next step. Okay, now let's study more properties of equality. First one is the reflexive property of equality. In real numbers, we will say a equals to a, means 7 is equals to 7. Every real number is equals to itself. This is a property. Okay, this property is called the reflexive property of equality. In terms of line segments, we can have this property that the line segment AB is equals to the line segment AB. Okay, why we exclude um, line in that and ray? We can't say that two lines are equal, two rays are equal. Why? Because there is no known length or exact length. A line has no exact length. Okay, and similarly for a line and for a ray there is no endpoint. Just due to these reasons we cannot say what is the length of a line. Okay, and what is the length of the other line, so we cannot make them equal. Clear? We can make them, we can write the line segments are equal because their measure is same. They can have the same length. A line cannot have the length of 5, but a line segment have a length of 5 meter, 5 centimeter, 5 millimeter, etc. Okay. Similarly, for array there is one endpoint. It also doesn't have um, it also doesn't have it has its both endpoints are missing. For array it has only one endpoint, but because it is increasing in one side, this is a line, this is increasing in both sides, this is ray, it is increasing in one side, but again the problem is that how can we say that the other ray is equals to it, because its one endpoint is missing. We haven't any idea how long it will go. Clear? So this property is missing, the reflexive property is missing in line and ray. You have to keep it in your mind that we cannot apply the reflexive property in line and ray. We can apply it only in line segment. Okay, is it clear, beta?
Yeah.
Okay, and then we can apply it when we are measuring the angle. When we are measuring the angle, that um, angle A equals to measure angle A is equals to measure angle A. What does it mean now? When we say measure angle A equals to measure angle A means its angle measure. It can be. I'm just giving you an example. For example, if we say it is 60 degree. Okay, so 60 degree is equals to 60 degree. This is possible. Okay, if we are just talking about the angle, that angle A is we cannot write angle A equals to angle A, because the this equality relation it is for in case of the real numbers. Okay, they are not equal. We haven't any idea of their exact measure. Okay, so we will say that instead of writing the equality we will say that they are congruent. Angle A is congruent to angle A, but they are not equal. So in congruency they are reflexive, but not in equality. Similarly, a line, if we are taking the relation of the congruency, then the congruency relation between line is reflexive, but the equality relation is not reflexive. Okay, so it is just a little more confusing things and more interesting. Particularly, being a mathematician, I will say these are the interesting facts about the equality, congruency, reflexiveness. But being a student, you will say these are the boring stuff. But for me, they are very interesting. Okay, moving forward. The next property is the symmetric property. What does it mean? That means, in terms of real numbers, if a number A is equals to number B, then number B is equals to number A. real number b is equals to real number a. Again, if I say a 7 is equals to 7, now I am writing two different 7s. Okay, 7 is equals to 7. This implies this 7 is equals to this 7. This is a property of real numbers, that they are symmetric in nature. Okay, can you tell me the symmetric property? How can you write it in terms of the conditional statement and converse, contrapositive, etc.? What would be its uh, converse statement?
The transitive property.
Yeah, the set of properties, symmetric property. I'm talking about the symmetric property. What would be its converse statement? Hmm? We already studied about the converse statement, negation, and then contrapositive statement, right? And we studied that we have a consensus on that point, that the conditional statement and the contrapositive statement, they are equivalent, right? Means if we are proving a statement by the direct statement, we are unable to prove that. It is easier to prove its contrapositive. We will prove its contrapositive statement. Now my question is, what is its converse statement, and is it true or wrong?
So if B is equal to A, then A is equal to B.
Yes, very good. If b equals to a, then a equals to b. You know that the conclusion will become hypothesis, and hypothesis will turn into the conclusion. This is the converse statement, right?
Yeah.
Excellent. Okay, now this property also holds in terms of the measure length of the line segment, that if a equals to a, the line segment ab is equals to the line segment this is again segment length. Usually we write for them measure, okay, but they, because they mentioned, so they are not writing it. Okay, then cd would be equals to ab. Okay, so this is also true. It's same, just like the same case. For example, if I say ab has the length of 7 and cd also have the length of 7, then 7 will be equals to 7, for so we can uh, write it in that way. This is property is called the symmetric property of segment length. Hmm. Next is the measure angle property. Again, if two for two angles, if their angle measures are equal, then the angle measure of B would be equals to the angle measure of A. Okay, this property is known as symmetric property of angle measure. Is it clear, beta? Okay, Dua. Let's move to the next property, which is the transitive property. Now, it's been more interesting that what is the transitive property of real numbers. For example, if real number a equals to real number b, and real number b equals to real number c, then real number a will be equals to real number c. Let me give you its example. For example, if I just now I'm writing 7 in three different forms. This 7 equals to this 7, and 7 with cut equals to um, this 7 with the curve, then the first 7 will equals to the last 7. But this is very interesting and very complicated property, the transitive property, because for you equality is just the equality, but it is basically a relation. Okay, similarly, if somehow in learning about the measure length, if we establish that their lengths are equal, okay, if AB is equals to CD and then CD is equals to some EF, then AB will become equals to EF. Okay, the first one will become equals to the third one. We can omit, or we can skip the middle one. Clear?
Yeah.
Okay, and in the last one, if the measure angle, if the angle measure angle A is equals to the measure angle B and measure angle B is equals to measure angle C, then measure angle A will become equals to measure angle C. It is for angle measure. Okay, now look at question number 7.
If M is
Measure angle
equal.
6 is means the there is a shape with 6 or 7 angles. Okay, then there's sixth angle and the length, the measure of the sixth angle and the measure of the seventh angle, they are equal. So we will say that the measure angle 7 is equals to the measure angle 6. So which property is this property? Hmm? It is symmetric property. Symmetric property of angle measure. Okay,
Hmm.
and this is symmetric property of angle measure. Okay, 34 degree is equals to 34 degree. Which property is this?
Um. Re, reflexive property, real numbers.
No, 34 is a real number. 34 degree is not a real number. Okay,
Oh, so it would be angle measures.
angle measures, reflexive property of angle measures. Okay,
Hmm.
okay. What about question number 9? Measure angle 1 equals to measure angle 2, and measure angle 2 equals to measure angle 5. So measure angle 1 equals to measure angle 5. Which property is this one?
Transitive property, angle with of angle measures.
Okay, good. This is the transitive property of angle measures. Excellent. Very good. Hmm. Look at question number 3. You have to justify each step. You are given with a statement, and from the first statement you are getting the second statement. Okay, but this second statement you cannot get if you have some if you haven't some properties of equality. So which properties of equality are you using in each step? What you did from this step to this step, from the first to the second one? So Dua, what you did, beta, how you get this equation, how you got that? You got that by subtracting negative by subtracting 7 from both sides, right? So if you subtracted 7 from both sides, that means you applied subtraction property of equality.
So then the second one would be
Hmm.
addition
Property of equality, right? Yeah, but can you just, I know you got it. Can you just tell me what we did in this step?
you add 12
Okay, on
to
both
both
sides.
sides.
Mhm.
Then for this one, they divide -4
Mhm. So which property we
sides.
used?
Division property of equality.
Okay.
First, they distributed 5x. They distributed 5 to x, and
Mhm.
then
So we will say which property is it?
a distributive property
Distributive property of addition or subtraction?
of subtraction.
Okay, then write it. Excellent. And what about the next step?
They subtract 4x both sides.
Mhm.
So subtract
So it is the subtraction property of.
of equality.
Okay.
They add 5 both sides.
Mhm.
So the addition
Okay, Dua beta, you can solve the remaining questions. I can understand. Please move to question number. First, try to solve question number 24. This is basically what you have to do. You have to make subject to a variable. Okay, if you please scroll down. So you
yeah.
can see question number 24. It is x is equals to 2 pi r square plus 2 pi r h. You are given with this formula. Okay.
Mm-hmm. So solve each.
No, you have to solve it for h. Means from this formula, what you have to do, you have to get the value of h. Okay. Should I solve, or you can?
Okay.
Okay. Then by using the properties, okay, by using the basic properties of equality, we have to solve
So
it.
s minus 2
How can you do that?
or
This is equality sign.
oh
This is the equality sign. Yeah. 2 pi r h. Hmm. Then
so
so in the first step, what I am doing, I am subtracting 2 pi r square from both sides. Okay, by using subtraction property of equality. Okay,
mhm.
so I will get s minus 2 pi r square, that is equals to 2 pi r h. Okay, and
And
now
then
because I have to make h as my subtract, so I am dividing with 2 pi r on both sides by using the subtract division property of equality. You have to
division
write,
process of
you have to
equality.
write, yeah, it is, let me write it, division property of equality. Okay, so you will get s minus, oh dua beta, it is h, it's not capital H.
Oh,
Okay, yeah, s minus 2 pi r squared by 2 pi r. Okay, so what we did, we made h as a subject. Got it? Very easy
yes.
question. Okay, let's move to question number 25.
I have to take a Quran class.
Oh, okay. Thank you so much. See you tomorrow.